Rational Functions Part 1. Find the domain of the following rational function. Here I have a rational function because I have variables in the denominator. In order to identify the domain, I'm going to set the denominator equal to 0 and solve for x. This gives me the values that x cannot equal. So I'll set the denominator equal to 0, and I have x minus 7 times x plus 8 equals 0. Since this is already factored, I'm going to take each factor and set those equal to 0 and solve for x in each equation. The first equation, I'll add 7 to both sides and I get x equals 7. For the second equation, I'll subtract 8 from both sides and I get x equals negative 8. Now again, these are the values that x cannot equal because my denominator will go to 0 if they do. So the domain is all real numbers except for 7 and negative 8. And I can write this in set builder notation as x and x cannot equal 7 and negative 8. And this is my final answer. Use the graph of the rational function to complete the following statement. As x approaches negative 2 to the right, f of x approaches what? Now notice that this plus sign in the upper right corner of my negative 2 tells me that I'm approaching negative 2 from the right. So I'll start here and I'm approaching negative 2 this way. So as I get closer and closer to negative 2, where is my graph going? And remember, I'm approaching it from the right. So that means that my y values are up here on this blue line. And my y values keep on going and going to positive infinity. So my answer is as x approaches negative 2 on the right, f of x approaches infinity, or positive infinity. Find the vertical asymptotes, if any, and the values of x corresponding to holes, if any, of the graph of the rational function. Now, rational functions have asymptotes, which are dotted lines on the graph, and the graph of the rational function cannot cross or touch these dotted lines. So, we're asked to find the vertical asymptote, which is the vertical dashed line that the graph cannot cross or touch. In order to do this, you first want to make sure that the numerator and denominator are factored. If we look at this function, the numerator and denominator are both factored. Now, we want to see if we can cancel any like factors. And as you can see, I have an x on top and an x on the bottom. So those can cancel out. Whenever you cancel a like factor, that means that you'll have a hole on the graph. So there's going to be a hole at x equals 0. And I know that because you just take the factor that you canceled and set it equal to 0 and solve for x. So if I set x equal to 0, that's already solved. So I know that there's a hole at x equals 0. Next, I'm going to find the line of the vertical asymptote. So I'm going to take the denominator of the simplified expression, which is 1 over x minus 8. So I'll take the denominator, x minus 8, and set it equal to 0 and solve for x. And I get x equals 8. That tells me that the vertical asymptote is a vertical line at x equals 8. And these are my two answers. Find the horizontal asymptote, if any, of the graph of the rational function. In order to identify the horizontal asymptote, we're going to look at the degrees of the numerator and the denominator. The degree is the highest exponent. So if I look at the numerator, the highest exponent is 2. And if I look at the denominator, the highest exponent is also 2. Since the degrees are equal, that means that the horizontal asymptote is found by dividing the leading coefficient of the numerator by the leading coefficient of the denominator. The leading coefficient of the numerator is the coefficient next to the variable with the highest degree. So that would be 10. And we're dividing that by the leading coefficient of the denominator. And the leading coefficient of the denominator is 5. And 10 divided by 5 is 2. So there is a horizontal asymptote at y equals 2.